Hi there, I'm Mrs McTaggart and I'm going to do a video today on writing scientific notation back to normal form. So that means writing it back in full, and I'm focusing on tiny numbers. Now this is part 4 in a series of lessons on scientific notation. Before now you should have seen already how to work to and from big numbers, and then how to change tiny numbers into scientific notation, because it's the reverse of that today we're doing. Okay, so I'm going to start you off with this example here. 3.4 times 10 to the power minus 3. Please remember that numbers with negative powers means that it's an absolutely tiny number, okay? I don't want anyone to think, oh, the power means you move it 3 places and then move it 3 places the other way. For example, you could say, right, that's going to be 34, decimal points move in 1 place, 2 places, 3 places, and you'll think that's the answer. That's wrong. That's a big number. That's what it would have been if it said times 10 to the 3 on the end. So the fact that it's got a negative power, you have to think, oh, my point is going the other way. So it's not moving right, it's moving left. So our point is moving left today. So let's have a look. Now I've got I'm fortunate enough to be able to write this out and rub it out as I go. Doing it in pencil or anything, or a bit of scrap paper, you can do the exact same. So if I start with a 3.4 and I'm going to move it 3 places to the left, so I'm going to go 1, 2, 3. There's where my new decimal point is going to go. So I have to fill the spaces with zeros, so I have to put a 0 there, a 0 there, and a 0 there. So that is my answer to 3.4 times 10 to the negative 3. It is 0.0034. But if you were listening to my last video carefully, there was a little trick with these ones. When it said power minus 3, you had 3 zeros at the start of the number. That was the connection, that was the trick. Yes, the power mathematically is how many places you're moving the decimal point. But with teeny tiny numbers, it's also connected with the number zeros at the beginning. So there is a trick for this one. I'm going to do each example both ways, okay? So 7 times 10 to the minus 3, that means I'm moving my decimal point 3 places. Remember, we're always moving our point to the left today. Now, there's no decimal point on the number 7, so remember it's hiding. So it's like having it here at the end of the number, and it's going to go 1, 2, 3. So it's going to go there. I've got a gap, and I have to put a 0 at the front. So this is 0.007. Okay. My second example, minus 5, means I'm going to move my dot 5 places. So if I've got 5.1, 1, 2, 3, 4, 5 means it goes there. I've got to fill in all these spaces. So I have got 0.4051 as my answer. Now remember that connection, power minus 3, 3 zeros, power minus 5, 5 zeros. So I'm going to use that for the next couple of examples. So here is the trick. However many zeros you have for the power, write that down first of all. So if it said power times 10 to the minus 5, we are going to write down 1, 2, 3, 4, 5 zeros. That's step 1. Then we put the dot after the first zero, so it should always be 0 point. Now you might prefer to start off and go, right, I need 5, so that's 0 point, I need 4 more. That's both the same thing. So either way, we've got our 5 zeros at the beginning and our dot after the first dot. And then you write down whatever the number I gave to you was. So if I gave you 3.6, you add on a 3.6 without the decimal point, because you can only have one decimal point in a number. What I do not want to see, guys, is people do this. Mathematically, it's not possible to have 2 decimal points, okay? So that is bad. So let's do the trick for some examples now. So 4.12 times 10 to the minus 1. Minus 1 means I have got 1 0. So put down 1 0, my dot after the first 0, and then my number 412 as it was. And remember, I was just moving that point 1 place to there anyway, so it was 0.412. This one, 9.732 to the power negative 6. So I need 6 zeros at the start. So I'm going to do 1, 2, 3, 4, 5, 6. My decimal point has to go after that first one. And then I'm going to put in the rest of the numbers, which is 9, 7, 3, 2. Had to squeeze that in there a wee bit. Okay, so remember 6 zeros all in, and you can always double check. Get your pencil and go check the decimal point. Check that the decimal points go back the way. So counting back the way, 1, 2, 3, 4, 5, 6 takes it back to between the 9 and the 7. So you can always do that wee check. Same with this one over here. Check that moving it back one place gives you the answer the number that you started with. Okay, so my last two examples, 3.87 times 10 to the negative 2. So the negative 2 tells me I need to put down 2 zeros. So 0.0387. If I want to do my little check, I'm just going to check moving my dot 2 places. Takes me back to where I started, and it does. It would have put the dot in between the 3 and the 8, which is where I started. Okay, so for my next example, we've got 3.33 times 10 to the negative 8. So we're going to have a lot of zeros this time. So 8 zeros, I'm going to come down here. I'll have 0 point, that's 1. So I need to put on another 7. 1, 2, 3, 4, 5, 6, 7. So there's my 7 zeros. 3, 3, 3. And remember, you can always do that little check. I'm just going to do it using the bumps. 1, 2, 3, 4, 5, 6, 7, 8. Takes me back to where I was. So there are your answers to the first 6 examples, and I hope you've got on okay with them. So this is a point where if you want to pause, you can try some of my examples, and then when you unpause, the questions will be on the next slide. So there's the answers there. Hopefully you've got on okay, and thank you very much for watching. Bye bye.